Welcome back to the Deep Dive, everybody. Today, we're taking a look at something pretty mind-blowing. We're going to be diving into how artificial intelligence, AI, is changing the way we discover new galaxies out there in the vast universe.
That's exciting.
It is. We're going to explore how AI helps us sift through these massive, and I mean massive, amounts of data that telescopes like Euclid are beaming back to us.
Yeah, Euclid is producing an incredible amount of information.
Exactly. And we'll talk about how this AI is helping us find these things called gravitational lenses, which are like these cosmic magnifying glasses. And we're also going to look at how AI is helping us to reconstruct the actual shapes of these really, really distant galaxies.
It's like AI is giving us a clearer view of the universe.
Right, like cleaning up those blurry old space photos, but on a cosmic scale. And we can't forget the amazing human-AI partnerships that are driving these discoveries.
Absolutely. The collaboration between scientists and AI is key.
Couldn't agree more. And of course, we'll highlight some of the recent amazing discoveries from the Euclid telescope. But before we get started, a little request. We'd love to hit 1,000 subscribers on YouTube for the podcast to fit.
Yeah, every subscriber helps.
Definitely. So if you enjoyed this deep dive, head over to YouTube and give us a sub. Okay, so let's get into it. I mean, where do we even begin with AI finding these incredibly distant galaxies?
Well, the biggest hurdle is the sheer scale of the data. Telescopes like Euclid are generating an unbelievable amount of data.
It's mind-boggling, right?
It really is. And AI gives us the tools to analyze this cosmic haystack quickly and efficiently. We're specifically looking for signs of gravitational lensing.
Gravitational lensing.
Yeah, those distortions in light that tell us a massive object is bending the light coming from a galaxy behind it.
Ah, so it's like the light from the distant galaxy gets bent around a massive object, and we see that distortion.
Exactly. And that distortion is a sign that there's something massive out there, potentially a whole galaxy, that we might not otherwise be able to see.
Wow. So Euclid is using AI to hunt down these gravitational lenses.
Yes, and it's been incredibly successful. Just in the first week of operation, Euclid's AI identified 500 strong gravitational lens candidates.
500 in a week. That's amazing.
It really is. That initial number blew away everyone's expectations.
Yeah.
It shows just how good AI is at processing this complex astronomical data and finding those subtle patterns.
I bet the scientists were thrilled.
Absolutely. And Euclid is aiming to catalog 100,000 galaxy lenses over its mission lifetime. So this early success is a really good sign.
That's a lot of lenses. So AI is like our cosmic detective, finding these clues to hidden galaxies. But what about when those images from the telescope, what if they're still blurry or distorted? Can AI help us get a clearer picture?
It definitely can. This is where some really cool AI technology comes in. Specifically, we're talking about Generative Adversarial Networks, or GANs, that were developed in Japan.
GANs.
Yeah. Imagine two AI systems kind of competing with each other.
Competing. How does that help with galaxy images?
Well, one AI tries to reconstruct the galaxy image as it will look without the lens distortion. The other AI is trying to figure out if that reconstruction is real or fake.
So they're challenging each other to get better.
Exactly. This back and forth, this constant learning process, makes the first AI really good at undoing the effects of the gravitational lens. It allows us to see the true shape of that distant galaxy.
So it's like AI is digitally removing the distortions caused by these massive objects.
That's a great way to put it. It's like AI is giving us a cosmic Photoshop tool.
I love that. Cosmic Photoshop. So this must require some pretty heavy-duty computing power.
Oh, absolutely. This level of image processing and analysis needs serious muscle. That's where supercomputers like Ada Ruy-2 in Japan come in.
Ada Ruy-2.
Yeah, it provides the computing power needed to run these complex AI models.
It seems like AI is essential for dealing with all this data, but it's not like AI is replacing human astronomers, right?
No, not at all. The real magic happens when human expertise and AI automation work together.
A partnership.
Precisely. A great example of this is the Galaxy Zoo project.
Galaxy Zoo.
Yes. In this project, you have thousands of volunteers, everyday people, classifying galaxies. Almost 10,000 volunteers manually looked at and categorized countless galaxy images.
Wow, that's a lot of people power. What did they do with all that data?
This data, all these human-labeled images, became the training ground for an AI called Zubot.
Zubot. So are you saying that these citizen scientists were teaching an AI what different galaxies look like?
Exactly. By learning from all those human classifications, Zubot became incredibly good at analyzing galaxy images on its own.
That's amazing. So now Zubot can do the heavy lifting, and the scientists can focus on the really tricky or unusual cases.
That's the idea. It frees up the scientists to do what they do best, which is to interpret and understand the data.
So it's a win-win. AI gets smarter, and the scientists can focus on the big picture. But it's not just a one-way street, right? Humans training AI. The AI's findings are also being checked by humans, right?
Absolutely. The results from Zubot are then validated by both professional astronomers and those same citizen scientists who helped to train it.
So it's a continuous feedback loop, with humans and AI working together.
Exactly. This back and forth ensures that the discoveries made with AI are accurate and reliable. This collaborative approach has actually doubled the number of gravitational lenses identified in some studies.
Wow, that's a huge impact. And we're already seeing the results of this collaboration with the first data release from Euclid.
We are. That first data catalog from Euclid includes classifications for over 380,000 galaxies. And get this, all those classifications were done by Zubot, the AI trained by all those Galaxy Zoo volunteers.
That's fantastic. A real-world example of the power of this human-AI partnership.
Yeah.
But I have to ask, going back to the sheer volume of data from Euclid, you mentioned it's like 200 days of HD video, right?
Yeah.
Per delivery.
That's right.
How can scientists even begin to make sense of that without AI?
That's the key point. AI isn't just helpful, it's essential. Without it, we simply couldn't handle that amount of data. It would be impossible to extract any meaningful information.
So AI is the key to unlocking the secrets hidden within all this data.
Exactly. AI allows us to go beyond just studying individual objects and start to analyze billions of galaxies statistically.
So AI isn't just helping us find those spectacular, obvious things like strong gravitational lenses.
No, it's also allowing us to study these really subtle phenomena that are happening across the entire universe.
Like what?
Well, think about weak gravitational lensing. These are tiny distortions in the light from billions of background galaxies. They're so small you can't see them with the naked eye, but AI can detect those patterns across vast distances.
That's incredible. So by looking at these tiny, almost invisible distortions, scientists can map the distribution of mass, including dark matter, over billions of light years.
Precisely. It's mind-blowing, really.
It really is. And Euclid's early discoveries, made possible by AI, have already given us some amazing insights into the universe.
Oh, absolutely. One of the most surprising findings was the discovery of 1.5 trillion orphan stars in the Perseus cluster.
1.5 trillion. That's an insane number of stars.
Yeah.
What are orphan stars?
These are stars that have been ejected from their original galaxies. This huge population of orphan stars tells us that the history of galaxy interactions within these clusters is much more dynamic and violent than we previously thought.
So galaxies are bumping into each other and flinging stars out into space.
It seems that way. It's a cosmic dance full of collisions and fireworks.
That's an incredible image. And Euclid also spotted a massive number of galaxies in its first observations, right?
It did. In just 1 week, it detected 26 million galaxies in 3 small patches of the sky. Some of the light from those galaxies has been traveling for 10.5 billion years.
We're talking about looking back in time to the early universe.
Exactly. And then, of course, there's the unexpected abundance of gravitational lenses. Those 500 strong candidates identified in the first week.
That was a big surprise.
It was. It really shows the power of AI to find these rare cosmic alignments. But Euclid's early observations were incredibly diverse. In the first 24 hours, it captured everything from nearby gas clouds to distant galaxy clusters.
A real cosmic smorgasbord.
It was. And there were even hints of rogue planets floating out there in interstellar space.
Rogue planets. Planets that aren't orbiting a star.
Yes. Euclid identified candidate rogue planets with masses about 4 times that of Jupiter. These are objects that are just drifting through space, not bound to any star.
That's fascinating. And Euclid is also helping us to learn more about dwarf galaxies, right? Those smaller galaxies that are kind of like the building blocks of larger ones.
Yes. Euclid is finding a rich harvest of newly discovered dwarf galaxies. These are crucial for understanding how galaxies form and evolve, and it all comes back to that first data release, with over 380,000 galaxies classified by Zubot, which was trained by nearly 10,000 volunteers.
It's a testament to the power of human-AI collaboration.
It truly is, and remember, that initial catalog represents less than 0.5% of the total galaxies that Euclid is expected to observe.
We've just scratched the surface. That's incredible. It's mind-blowing to think about how much data is still to come and the potential for even more groundbreaking discoveries. It really feels like we're at the dawn of a new era of cosmic exploration, driven by AI.
I completely agree.
The impact of AI on our understanding of the universe, particularly in finding these new galaxies through gravitational lensing, is undeniable. Missions like Euclid, empowered by AI and the invaluable contributions of citizen scientists, are poised to revolutionize our view of the cosmos. I think it leaves us with a sense of wonder and a burning question. Just how far will our understanding of the universe's structure and evolution deepen as AI continues to evolve?
That's a question for the future.
And that's it for this deep talk. Thanks for joining us.
It was a pleasure.
Don't forget to check out Loop Podcast with Philippe on YouTube and help us get to 1,000 subscribers. Until next time.
See you then.